Square roots are one of the more common problems dealing with radical symbols. And basically what it means is that we're looking for items that can be broken down into pairs of twos. So an example might say simplify. What happens when I have the square root of 25? Now, when we're looking at this, remember that this sign right here, this little symbol right here, and I'm just going to change it just so you can see that color again. That's our radical symbol. Remember that this number underneath is called our radicand. So just so you remember seeing these words and hearing these. And our index number, notice there's no number here. There's no value that's actually in this particular spot here. That's because for square roots, it's so common that we just assume that you will know that there's a 2 there. So if you don't see a number, you can assume that that means it's a 2, it's a square root. Any other time, cube root, fourth roots will put a number in there, that index number. So remember that phrase, that index. All right, so back to our problem is, we're now looking at, can I break down 25 into numbers that multiply together that would be in a pair of twos? So if we look, 5 times 5 is 25. And how many numbers do I have? Well, I have a pair of 2. So then what does our value come out to be in this problem? Well, it comes out to be 5. Okay, so if we're just asking you to simplify, I'm looking for what value will break down and give me that solution. What happens if I give you one like this that says simplify? And let's do a number like the square root of 18. Alright, well we're still going to try and break these down into prime numbers. So we're going to try and break this down as simple as we can. So 18 breaks down into 2 times 3 times 3. Right? 3 times 3 is 9, times 2 is 18. Well, we have a pair, right? So that's good. But we also have what we call sort of this leftover number, right? This number that didn't have a pair. So what does that do to our final solution? Well, for our final solution, that means we could take the pair out, and the number that's left over, that remainder piece, will just go back underneath the symbol. Remember, we're always multiplying, so if for some odd reason we had more numbers, we would multiply those back together again. But that's our simplified version of that. Let's look at one more case. One more case where we could be dealing with the square root. So let's look at something that says solve. Now this does change what we're looking at. Now we're solving for a variable. It says what number squared would give me 25? What number could I square and get 25? Now a lot of people will get this answer wrong on their test because they only think about the number 5. Really, what I'm trying to do on this one is I'm going to take the square root here, because the square root of a square root, like these two right there, will cancel out, and it will just leave me the x. Well, on the other side, when I take that square root, here's where it gets a little tricky because we're solving. What ends up on this one is we actually end up with plus or minus 5. Now, why do I get both those solutions? Well, if I take 5 and I square it, I get 25. What happens if I take negative 5 and I square it? Well, what's negative 5 times negative 5? Well, what's a negative times a negative? That would be a positive. And 5 times 5 would give me 25. So notice I get the same result. So both of those solutions will work. Therefore, when I solve it, I get plus or minus. I get both those answers as a final solution. So simplify, you'll only get the positive. Solve, you'll get both.